A restaurant chain uses a point-of-sale platform backed by Amazon DynamoDB. The system experiences a 4-hour daily peak and significantly lower activity otherwise. The table is currently set to provisioned throughput with 100,000 read capacity units and 80,000 write capacity units to handle that peak. Which approach provides the highest cost efficiency while reducing management tasks? Option A, manually decrease the provision throughput. Option B, transition to on-demand mode. Option C, implement autoscaling. Option D, acquire 1-year reserved capacity. The correct answer is option B, transition to on-demand mode. This is a common challenge you face with service providers like Amazon DynamoDB. You have a table that spikes with a known traffic pattern and then drops significantly afterward. The advantage of choosing on-demand mode is that DynamoDB automatically scales capacity up and down based on usage, saving a significant amount of money during those slow periods. Also, it removes all the management tasks from having to manually lower the capacity after the peak. Now, let's look at the other options. Option A is a good manual solution, but reserved capacity also provides the lowest cost, so option D will take precedence. Option C is implementing autoscaling. This technically is a good solution, and you have to provision what a high capacity for a while. Acquiring 1-year reserved capacity will provide the best cost efficiency. Option A is a good manual solution, but reserved capacity also provides the lowest cost, so option D will take precedence. Option C is implementing autoscaling. This technically is a good solution, and you have to provision what a high capacity for a while. Acquiring 1-year reserved capacity will provide the best cost efficiency.
This question focuses on how we manage database throughput in a cloud environment. It asks us to balance performance needs during specific high traffic periods with the goal of minimizing unnecessary costs during off-peak times, all while keeping administrative work to a minimum. We need to evaluate the most effective way to align provisioned resources with actual usage patterns. In my view, the correct answer is C. Implement DynamoDB autoscaling for the table. DynamoDB autoscaling is ideal here because it automatically adjusts throughput based on real traffic. Since the workload follows a predictable 4-hour pattern, the system can scale down during off-peak times, significantly saving on costs without requiring constant manual intervention from the IT team.
Let's look at why the other options are not the best fit. Option A, manual adjustment, creates an unnecessary administrative burden and risks throttling if not timed perfectly. Option B, on-demand capacity, is generally more expensive for high-volume, predictable workloads compared to provisioned capacity. Finally, option D, reserved capacity, is inefficient because you would be paying for peak capacity 24 hours a day, even when traffic is low.
A quick tip for the exam. When you see a predictable workload, always look for the solution that balances performance and cost based on those specific patterns. While on-demand is great for unpredictable spikes, autoscaling is usually the go-to answer for managing costs when you have clear cyclical traffic patterns that allow the system to effectively scale down during quieter periods.